what we're looking at now is called a Ritzville series soil. The Ritzville series soil has formed or developed under a much lower precipitation zone than the previously viewed Palouse series soil. Both of these are still silt loam soils. However, the difference between them is that the Ritzville series soil has a substantially higher content of fine sand and a much lower content of clay. So the Palouse is dominated more by clay in addition to the heavy silt content, whereas this Ritzville soil is dominated more by a fine sand, especially in the surface horizons, and a lower content of clay. This soil has formed in a zone of approximately 12 to 14 inches of annual precipitation. Now that doesn't sound substantially different than the 18 to 25 that we talked about on the Palouse, but it does make a significant difference in terms of the soil forming processes and the rate at which soil development occurs. In the surface horizon here, which extends, and we've got a good stand of grass on this soil, and we do see quite a lot of organic matter and the roots of these plants sticking out at the very surface of this soil monolith. However, this is still not an O horizon since it is dominated by mineral matter in and amongst that root matter. So we do have a very distinct A horizon here at the top. It proceeds down to a depth of approximately 30 centimeters. So we're calling this zone from the top of the soil down to this depth the top layer in this profile. Then we get into a zone here where we've had a little bit less darkening. We still have a good root mass down in here, and we see that it's very similar in color to the soil above, but we also begin to see at the base of this zone some whitey or chalky appearance in the soil profile. We're going to call this a second zone in the soil. It extends to a depth of approximately 17 centimeters. So we're talking about from here to the beginning of this whiter or chalkier zone. It's denoted more than anything else by a slight difference in soil structure. The structure here being different than it is up here above. As we progress below this zone, we're now getting into this layer of material that is very white and chalky in appearance. What this material is free lime, that's calcium carbonates, which have been leached or moved out, alluviated out of the zone above and redeposited in this zone down here below. So this is a zone where maximum accumulation again has occurred of a translocated or moved material in the soil profile. That material in this case being calcium carbonate or free lime in the soil. Now you'll also notice that at this region in the profile we did not have much success getting this material soil to hold together. The reason for that is if you get too high of a lime content, small amounts can act as a cementing agent. Larger amounts can actually cause the penetrating solutions that we use to make these soil monoliths to not wet and not hold the soil together. And that is indeed what has happened here, in that we didn't get good penetration and this soil has broken away from the board or from the monolith over time. So this zone extends from here to a depth of approximately 30 centimeters in the soil. So we're talking about the zone from here down to here, being approximately 30 centimeters in length. Below that, we also have a substantial amount of lime in the soil, but because we did not have extra lime alluviated from above and moved into this zone, here the soil held together quite well. It also held together well because we have a higher clay content down in this zone than we did in the soil above up here. So this zone in the soil extends pretty much down through the rest of the monolith. So we're going to start at this depth right here. We have 15, 30, approximately another 45 centimeters in depth. So we're basically saying from the bottom of this zone that broke out of the monolith down to the bottom of the monolith is all another distinct layer or horizon. So what I would like you to do now is to, with that information, to take the second sketched in diagram in your lab handout, trace in these horizons, indicate what you believe these horizons to be using the letters and or numbers that we have reviewed earlier in this lab period for indicating master horizons, sub-horizons, and or, if necessary, using lowercase letters to indicate zones of accumulation of certain types of material in the soil profile. Once you've completed that, then complete the review questions that are also associated with this lab, and please send that material in to me.